Green Edge scientists have a powerful tool in which to study phytoplankton blooms and the sea ice, which is not found on board the Amundsen, but rather found hundreds of kilometers above, orbiting the planet. Satellites provide the big picture of what's happening in the Arctic Ocean, far beyond the capabilities of field testing.
Nous allons beaucoup utiliser les satellites pour suivre l'évolution de cet événement de floraison printanière, mais pas seulement en baie de Baffin, partout en Arctique.
Marcel Babin at the University of Laval works with optical remote sensing. So he's using satellites that use the same light that your eyes are sensitive to, and he can use it to measure the chlorophyll in the water column and tell about the quality of the spring blooms, for instance, in the Arctic.
Remote sensing satellites are the most invaluable, as they utilize electromagnetic waves to study the properties of sea and ice. Visible light, ultraviolet radiation, and microwaves are used to sense the Earth's environment to calculate everything from the thickness and coverage of sea ice to sea surface temperature to the size and color of phytoplankton blooms.
Le phytoplancton est un végétal qui fait la photosynthèse, donc il fixe du gaz carbonique. Donc on a une estimation de la quantité de gaz carbonique qui rentre par l'intermédiaire de ce qu'on appelle la pompe biologique.
The RADARSAT-2 satellite is equipped with the radar synthetic aperture, which beams microwaves to the Earth's surface and measures the time it takes for the waves to bounce back.
My research group works more with the microwave portion of the spectrum. So we use light that you can't see with your eye. It doesn't matter if it's day or night, it doesn't matter if it's cloud covered. You can see right through all of those things to tell you some very detailed information about the physics of the ice, its thermodynamic state, which is essentially how warm is it, and what that ice is doing, how fast it's moving, and that can tell you a lot about the physical system.
The data collected, when fed into mathematical models, provides a picture of how the sea ice reacts to changing seasons and weather patterns in the context of climate change. The Cryosat-2 satellite uses altimetry, bouncing microwaves off the surface of the ocean to measure sea levels and the roughness of the ocean's surface. The satellite, an ESA project with the cooperation of France's CNES, also observes the evolution of polar ice coverage and thickness over an entire year by using a series of very short radar pulses that have an accuracy within 2 to 5 centimeters. The GCOM satellite is part of a Japanese program of 6 satellites that detects sea ice concentration using a radiometer sensor called the AMSR-2. Over the course of a season, the GCOM satellites can follow the progression of sea ice coverage and thickness as the climate warms and cools.
Pour essayer, à partir de ces images satellitaires-là, qui elles roulent à l'année, de faire d'avoir des mesures prises en simultané au niveau optique et au niveau purement de l'écologie, donc prélever des échantillons de ces organismes-là, du phytoplancton, pour essayer de trouver le meilleur algorithme, la meilleure formule magique qui permet, à partir de cette formule mathématique-là, de parler de la production à l'échelle annuelle et sur une grande étendue.
The color of the ocean and phytoplankton, as observed by satellites, is the result of the detection of the A chlorophyll pigment present in phytoplankton. The abundance, size, and species of phytoplankton can affect or contribute to the color of the water. Green areas show us where a chlorophyll A pigment in phytoplankton absorb blue and red light from the sun, leaving only the green light to return to our eye. Satellites use their sensors to observe this interaction of sunlight with marine particles. The appropriately named satellite Aqua uses the MODIS sensor, Moderate Resolution Imaging Spectrometer, to utilize 16 wavelength bands to provide an eye-in-the-sky view of the colorful phytoplankton blooms. The SUMI satellite is equipped with a visible infrared imaging radiometer suite, providing visible and infrared images of the ocean, sea ice, atmosphere, and land surfaces. It can also detect the color of the ocean as well as the surface temperature.
Les photons qui rentrent dans l'océan, il y en a un certain nombre qui sont renvoyés par diffusion, justement, qui sont renvoyés à l'extérieur. Il en est d'autant moins renvoyés qu'ils ont plus été absorbés.
The OLCI sensor allows the Sentinel-3 satellite to measure the nuances of ocean colors and the biological activity on the surface, even providing information on the content of chlorophyll and phytoplankton in the colorful blooms seen from high above. Field instruments that are deployed by Green Edge scientists aboard the Edmondson, such as gliders and floats, use an array of 90 Iridium telecommunication satellites, which allows scientists to send new commands or geolock locations.
The reason we want to be in contact with the gliders as much as possible, when they come up, we have the opportunity to communicate with them via the satellite phone. And the satellite phone phones into a server which connects to our server at University of Laval. And one of those things that we can do is send it a very short file with new latitude and longitude coordinates, where to go to under the ice, where to come back, or even if it's in open water.
Satellites have provided Green Edge scientists with an unparalleled view of the Arctic as a whole, providing complementary data to the on-site measurements conducted by the Green Edge team. And as satellite technology evolves, so does the understanding of the vast Arctic Ocean.
You know, groups like the European Space Agency, the Canadian Space Agency, NASA, Japanese Space Agency, Indian Space Agencies, they all are developing these tools and technology. And our research group worked very closely with them to help design what these satellites should look like, how we can, for instance, use both optical satellites, microwave satellites, near-infrared satellites, ultraviolet satellites, all in combination with one another to help us understand the changing Arctic.